Welcome back to 7th Science. Today we're going to be talking about friction and how it's a force. Scientists used to think that things would stop moving on their own, that essentially nothing moves forever. And that kind of makes sense. I mean, can you imagine throwing a ball across the room and it just going and going and going and going forever? It wasn't until Sir Isaac Newton came along to really prove those who thought, well, why did they stop on their own? Is there something that's causing them to stop their motion, or are they just deciding to stop moving because that's the way that the world works? Newton's first law of motion states that objects at rest will stay at rest, and objects in motion will continue their motion unless acted on by an outside force. Essentially, you can also rephrase it as objects tend to resist a change to their state of motion. This is also referred to as the law of inertia. In this video, I'm going to show you how friction is an outside force that acts on objects. So with this cardboard ramp and a few different objects, we'll show how friction is a force and that it acts on objects to disprove the theory that objects stop on their own. The four main types of friction are static, where objects are standing still, and it has friction, takes friction to let an object move or fall off. There's sliding friction, which is the friction that it takes friction once an object has started moving, which is less than static friction. Then there's rolling friction, which, as you probably know by now, is much less than static or sliding. In fact, objects really want to roll in resistance to that. And then there is fluid friction. Fluid friction is the friction that resists forward motion of an object through a fluid, like gas in the air in the atmosphere or through water. Let's look at static friction first. Static friction is friction force that keeps something from moving when it is at rest, which is Newton's law of inertia, or first law of motion. So this block right here, if you can see, is at rest, and these are already pretty smooth surfaces, so there shouldn't need to be a whole lot of gravitational force to overcome the force of friction, but let's try it anyway. So I'm going to change the angle of this right now. You can see if I do this slowly, that friction to hang on to right about there. So this is called static friction, when an object is at rest and it has a strong force resisting the force of gravity. So this is called static friction, when an object is at rest and it has a strong force resisting the force of gravity. Let's look at sliding friction next. So sliding friction is when an object resists its motion when it's already sliding across a flat surface. Like this block, when it starts moving, static friction allows it to keep moving even though we don't have to have as strong of a gravitational force. So gravitational force you can kind of visualize by how steep the incline is. I think we needed that angle right there to cause it to move. Let's change it, and so now that we're testing sliding friction, let's give it a little bit less of an angle and give it a little push. So the little push should, hopefully, if I'm not holding this too weakly, cause the block to show how static friction needs much less force, is a much less strong force resisting gravity or an object's motion. So here we go. Boom. Static friction is stronger than sliding friction. Let's look at another type of friction, rolling friction. So this one's an easy one to visualize. We have a ball here. Rolling friction is basically the force that keeps an object from rolling around. There is a small amount of friction as the ball turns. It's happening at the bottom here, where it's going to resist that motion essentially by turning. But it is, again, much less powerful than static friction or sliding friction. And you can see that just by, I have to actually try my best here to keep it flat, because rolling friction is so weak that the plane is, even at a slight angle, is always trying to cause the ball to move around. And then once it has momentum, it's kind of a game to keep it flat on the plate. So rolling friction is one of the weakest types of friction because it takes so little force to cause something to move when it has wheels or is round. The last thing that I want to look at, our last force or type of friction, is fluid friction, which is the resistance that an object has when it's passing through a fluid or gas substance like the air. So if you take a ball and drop it, there is resistance to gravity in air pressure here. You can think about if I had a giant fan pushing up and causing an upward force against this ball, it would fall slower because the air passing around the ball not only causes a force up, but it's causing more fluid friction. And fluid friction is super important. It's what happens when a spacecraft comes in out of the atmosphere. It starts to heat up. Scientists have to design spacecraft to absorb or repel heat and make as smooth of a surface as possible on their aircraft so that there isn't any unnecessary friction happening through fluid friction, which is still a strong force, but it is less strong than rolling force. So to recap, friction is a force. We can prove that by saying that objects at rest will stay at rest unless a force causes them to move. We have 4 different types of friction. There is static friction, where something is just still and it has a lot stronger force than static friction, where something is already moving, it will keep moving, and it's a weaker force than static friction. The next weakest force is rolling friction, which is the friction that happens on the bottom of a round surface where it's meeting the surface. There is some friction there. And that is a stronger force than fluid friction, which is the friction between an object and a fluid that it is interacting with. I hope that helps explain how friction is a force and the 4 different types of frictions. If you have any questions about this, you can always send me a comment in YouTube, or you can send me an email if you have my email, and I will try and answer those questions best I can.